Okay, the first question wants us to find the scale factor and the center of dilation. So to find the scale factor, it tells me to count the horizontal boxes on the pre-image and the image. Now remember, the pre-image is the shape without the little tick marks. So I can do 1, 2, 3, 4, 4 units long. And if I want to find the scale factor, the length of the other horizontal, the corresponding side, 1, 2, 3, 4, 5, 6, 7, 8. So you want to find the scale factor. What do I have to multiply the length on my pre-image to get my image? So 4 times 2, so my scale factor would be 2. And then if I want to find my center of dilation, I'm going to match up my points that correspond. So I can match up A and A prime, and I'm going to draw a line to connect those. And I want to match up E and E prime and take a line to connect those. And my center of dilation is going to be the point where they intersect, so that would be there. So the X coordinate would be 3, and my Y coordinate would be 6. So my center of dilation is at 3, 6. Now on this one, we want to do the same thing. So we're going to count the spaces on the horizontal side of my image, pre-image. And you want to count the spaces on your image. And that's going to give you your scale factor. The same thing with the center of dilation. I want to connect my corresponding points. So if I connect B and B prime, and I could connect E and E prime to draw lines. And it's the point where those meet. So you could get those. Do the same thing on this one. Find the scale factor and the center of dilation. On this question, if a polygon is dilated by a scale factor of 4, compare the image to the pre-image. Will the image will be smaller or larger? So think about it. If you multiply something by 4, you're going to get a larger value. Will it be closer or further to the center of dilation than the pre-image? So if you multiply it by a number greater than 1, it's going to be further away because it's going to have more ways to travel. If a polygon is dilated by a scale factor of 1/4, compare the image to the pre-image. So the image will be smaller or larger than the pre-image. If you multiply by 1/4, you're making the value smaller. Will the image be closer or further to the center of dilation than the pre-image? If you multiply by a small value, that's going to make it closer. If a polygon is dilated by a scale factor of 7, compare the image to the pre-image. Fill in the blanks. On this question, use the definition of similarity in terms of similar transformations to determine whether the figures are similar. The first question says, are the figures similar? Yes or no? I would say yes, they are the same shape, but they're different sizes. Circle the transformations. In this case, what I've done is I have dilated, and I could say I have translated, I have slide. So if I translate it, I moved it up 4 units, and I moved it left 6 units. That's how I describe my transformation. My dilation, I've got to determine the scale factor. So if I look at the scale factor, 1, 2 units, 1, 2, 3, 4 units. So my scale factor will be 4 times 2, or 2 times 2 is 4. So my scale factor is 2. Use the definition of similarity in terms of similar transformations to determine whether the two figures are similar. Are the two figures similar? Yes or no? Describe the transformations. In this one, I notice that it is reflected because it's upside down, it's flipped. And I notice that it is dilated because one's larger than the other. And I also notice that it is translated. So the last thing we want to do is describe the transformations. So if I describe the reflection, it's over the x-axis. If I describe my translation, I could say it moved down, and it moved right. In my dilation, I got to find my scale factor. So I count my units. So my scale factor would be 2. Now on this one, you need to do this one first. Are the figures similar? Describe or identify the transformations. And describe each transformation. On this one, we want to be able to identify the congruent corresponding angles, because angles are congruent in corresponding shapes or similar shapes, and name the proportional corresponding sides, because the sides are not equal, they are proportional. So we need to label the sides. Triangle ABC is similar to EFG. So if I want to name my angles that are congruent, I would say angle A is congruent to angle E. And I can see that in the picture. I also can see it in the statement. Angle B is congruent to angle F. Again, I see it in the picture and the statement. And angle C is congruent to angle G. I can see it in the picture. So next, I want to name my proportional sides. Now, I know they're proportional. They're not congruent because one shape's larger than the other one. So if I look at my first side, AB, AB is corresponding to EF. I can see that in the picture, and I also can see it in my statement. Next, I could say BC is corresponding to FG. And my last side is AC is corresponding to EG. So I name my corresponding congruent angles and my corresponding proportional sides. On this one, I need to label my triangles. So if I label my triangles using the statement here, I would have M, B, C, and R, S, T. And you want to name the congruent corresponding angles. You can use the statement or the picture. Name the proportional corresponding sides. Again, you can use the picture or you can use the statement. On this one, I want you to do the whole problem by yourself. So be sure to start with labeling the triangles. It'll be a good idea to write stuff down on a piece of paper or a marker. Name the congruent corresponding angles. Name the proportional corresponding sides. 13. Identify the similar triangles. Now remember, if they're similar, they're going to have the same scale factor. So if I look at the first two triangles here, I can say 8 divided by 2 is 4. 9 divided by 2 is 4.5. 10 divided by 2 is 5. So the scale factor is 1/2. So I want to make sure that I go in the same direction. So I would say Q, W, E. And if I start with the side that's 4, I'm going to say D, N, Y, because I have to go in the same one. Now, how do I know these are similar? AA stands for angle, angle. I have no information about angles. Side, side, side. SSS says that I have 3 pair of proportional sides. I have a scale factor for all sides, so that would be the reason why. On this one, Again, I need to identify the similar triangles. So if I look at this one, the first one and the last one, again, I notice they have a scale factor of 1/2 for all three sides. So if I name this side, I could say BX, M. If I look at the side that's 4, I would say AD, S. Again, what similarity theorem justifies, I'm only giving information about sides, so it would have to be side, side, side. All right, you do this one. Identify the similar triangles. Which similarity theorem justifies that the triangles are similar? Next question. Which similarity theorem explains why the two triangles are similar? All right, now, if I notice here, I have two triangles. I have the small triangle and I have the large triangle. I know two sides on my small triangle, but I only know one side on my large triangle. So it's going to have to be information about angles. Now, what angles do I have information about? I have no information in the picture. But if you look at this, you have these arrows. These arrows mean that we have parallel lines. So if I have parallel lines, I have corresponding angles and I have alternate interior angles. So I know angle L is congruent to angle K. And I also know that angle N is congruent to angle M. Those would be my two angles. So if I want to write my proportions, I'm going to say the left side I have 20 and X. And then on the right side, I have 15 and 12. So if I cross multiply to solve any proportion, that's going to give me 15x equals 20 times 12 is 240. So if I divide 240 by 12, or by 15, it's going to give me x equals 16. If I check to make sure my answer makes sense, I would say yes, because it's somewhere in the same vicinity. It's not an outrageous number. Now, how do I describe how I found x? Well, I set up my proportion. And I found the cross products. To solve. So I want you to do this one. Again, which similarity theorem explains why the two triangles are similar? I don't have enough information about sides to use side, 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 or side, angle, side. I do have the arrows, so I can identify my corresponding angles. The angles on the left and the angles on the right are congruent because they're corresponding. So I want you to set up your proportion and solve. So I would say the numbers on the left are x and 9. The numbers on the right are 21 and 7. So find your cross products to solve. $18. You want to do the same thing on this one? Which similarity theorem explains why the two triangles are similar? Write your proportion to solve and find x. And describe how you found x. 19. Circle the two values that are corresponding. So if I notice this side and this side are corresponding, they're in the same positions. What is the scale factor? Well, 4 times what factor equals 12? So my scale factor would be 3. So if I want to write my proportion to find Pn, here's Pn. So I'm going to say 4 over 12 equals 6 over x, because that corresponds. And I would cross multiply to solve, so I would say 4x equals 72. So I would have to divide to find the value. 72 divided by 4, so x is 18. Now, if I wanted to set up the proportion to find angle or let's see, I want to find XY. Let's see. So I want to find XY. Well, XY corresponds to 9. So I would use 4 over 12 equals Y over 9. And I would get my cross products. So I would say 12Y equals 36. If I use the division property, that would give me 3. Circle the two values that are corresponding. In this case, I know 3 and 9 are corresponding because they're in the same position. What is the scale factor? 3 times what factor? Equals 9. So write a proportion to find side PN. So to do that, I want to see what side PN corresponds to. PN corresponds to ZY. So I would use 3 over 9. Those are my corresponding values. Equals 5 over X. And I would cross multiply to find my answer. For the next problem, I want to find XY. So XY is this side. It corresponds to MN. So again, I would set up my proportion. 3 over 9 equals Y over 6. Cross multiply to find my answer. On this one, it might help if you write something down. The first thing you need to do is determine the scale factor. The next thing you need to do, set up your proportions and solve for PN. And the last thing you need to do, set up your proportions and solve for side XY. In order to estimate the height of a flagpole, Diaja, who is 5 feet tall, stands so that the tip of her shadow coincides with the tip of the flagpole shadow. Her shadow is 8 feet, and the shadow of the flagpole is 32 feet. So you want to place the values on the figure. I would use a smaller triangle for Diaja and the larger triangle for the flagpole. If Diaja is 5 feet tall, height's got to go on your vertical side. If her shadow is 8 feet tall, shadows go on the ground. And the shadow of the flagpole is 32. I want to find the height of the flagpole, so I would let that equal X. So I have to set up my proportion. So I would say 5.5 over 8 equals X over 32. So to solve that, I need to find my cross products. So 8X equals 5.5 times 32 is 176. So to determine the height of the flagpole, I need to divide 176 by 8. So that would tell me the flagpole is 22 feet tall. Now, which similarity theorem explains why the two triangles are similar? Well, I know in each triangle I have a right angle, and the sun gives the same angle of elevation, so that would give me angle. Same way on this one. In order to estimate the height of the flagpole, Darian, who is 6 feet tall, so I'm going to put 6 feet on the smaller triangle, stands so the tip of his shadow corresponds with the tip of the flagpole shadow. His shadow is 4 feet, and the shadow of the flagpole is 32 feet. So you want to find the height of the flagpole. So set up your proportion. Solve for X. And which similarity theorem explains? You know you don't have enough information for side, or side, angle, side. So that leaves one choice. You do this one. In order to estimate the height of the flagpole, Emma, who's 5.8 feet tall, stands so the tip of her shadow corresponds with the tip of the flagpole shadow. Her shadow is 10 feet, and the shadow of the flagpole is 30 feet. Write a proportion to find the height of the flagpole. Which similarity theorem explains why the two triangles are similar? (25) Highlight the given angles. So I want to highlight angle AFE is congruent to angle FCB? What type of angles are those? Well, I notice those angles are in the same position, so we would call those corresponding angles. Highlight the given angles. Angle RQS and angle UTS. I notice those are not in the same position. Those are called alternate interior angles. Highlight the given angles. Angle QSR and angle TSU. Identify what kind of angles they are. On these, we want to fill in the information, all right? So if HA is perpendicular to CS, then we know that we can do construction of a perpendicular line. The triangles CHS is similar to triangle CAH is similar to triangle HAS. So if we want to know that, why are the triangles similar? We got to use the similarity criteria. So that would be angle-angle similarity theorem. CH over CA equals CS over CH. That is a proportion. So you want to say corresponding sides are proportional. Two equal fractions is a proportion. Number 5, CH squared. I did that by multiplying, finding the cross products. 6, again, I have a proportion. SH over AS is equal to CS over SH. So those are corresponding sides are proportional. To get SH, I had to cross multiply. So those are cross products are equal. Number 8, CH squared plus SH squared equals CA times CS plus AS over CS. Now, to do that, I've combined, so I would say that's the addition property of equality. Number 9, CH squared plus S squared equals CS times CA plus AS. So that would be simplifying by using the greatest common factor. 10, CH squared plus SH squared equals CS times CS. So I've substituted in. Right, so that would be substitution. And then the last thing I've done is I've simplified because I've multiplied CS times CS. So there's my proof. On this one, number 1, CD is the perpendicular bisector of AB. How do I know that? Because it is given. 2, D is the midpoint of AB. Which reason would tell me that D is the midpoint of AB? I know D is the midpoint because I was told this was the bisector. AD is congruent to BD. Why would AD be congruent to BD? And that's because D is the midpoint. Angle ADC and angle BDC are right angles. How did I know that there's a right angle here? Because that's what perpendicular means. Perpendicular is two lines that form right angles. Angle ADC is congruent to angle BDC. That's because they are right angles, and all right angles are congruent. 6, CD would be congruent to CD. The reason that CD is congruent to itself is because when you look in the mirror, you see your reflection, the reflexive property. triangles ADC or ACD is congruent to triangle BCD. Remember, you have to use a criterion. Look at the flip book. So that would be side angle side. And AC is congruent to BC because they are corresponding parts that are in congruent triangles.